All right, so this one says to rotate it 120 degrees counterclockwise. So counterclockwise is going this way, against the way that the clock goes. These are triangles, they're 60 degrees. So this is 60 degrees, and then, let me zoom in a little bit. And then this is gonna be 60 degrees. So this line is going to move to where you have it drawn. So that part is good. And so it's about point D. So put your pencil down, and then you're gonna turn it. Well, you need to put point D on point D. 1, 2, and so it looks like you have it pretty much where it is supposed to go. It's gonna be off a little bit just because the paper is at an angle. So something, if you're not sure if it's exactly right, D to B here is 1, 2, 3 triangle links. So D to B, 1, 2, 3 triangle links. If you're not exactly sure, but yours looks pretty good. Okay. On number 2, there is an equilateral triangle, ABC inscribed in a circle, D. And what's the smallest angle? You can rotate it so that the image of A is B. So we're taking A and we're turning it to B. And if you turned it 3 times, it would be back onto itself. So 1, 2, and then 3. So you could do 360 divided by 3. And that would get you to the 120. And so you may, obviously you thought it was 60 because this angle here is 60 degrees. But if you rotate 60 degrees, let's see. Here's my rough triangle. There's the center of my circle. So here is my vertical, horizontal. So if I turn it 90 degrees, it's still going to look like a cross. And so, whoops, sorry. There's 90 degrees. And you can tell that the triangle is not back onto itself yet. And at no point has it gone back onto itself. So 60 would have been maybe here-ish. Hard to say exactly, but it would not have hit the triangle. And that's what it's wanting to know. When can that triangle be mapped back onto itself? And so it's going to be more than 90 degrees. It's actually, if I can get my paper to turn, it's going to be 120. If you had, let's see, 1, 2, 3, 4, 5 figure, a pentagon, I lost the name of it for a second. So 5, you would do 360 divided by 5. I know that's not what it asked for, which I believe is 72, yes. But basically you just take the number of sides of your figure or the number of dots, the corners of your figure, and you divide it by 360, and that tells you how many degrees you would have to turn it. Okay, on this one, a couple of things that I am looking at here. It says which segment is the image of AB. So A to B is 3 units long, which E to D, it's kind of hard to tell for sure, but the rest of them, I mean, all of them look like they're about 3, but you are looking for a segment because it says which segment is the image of AB. So it's not an angle that you're looking for. So your answer choices are going to be your segments. Is it still AB? Probably not. Is it segment BC? That's a segment. Is it ED? Is it FG, or is it HI? Those are the segments that it gives you in your figure. Then another thing, it says it's rotated 90 degrees counterclockwise. Well, you have your segment here. When it is rotated counterclockwise, it goes this way, 90 degrees, it's going to be a vertical segment. So out of those, it's not going to be AB. It's not going to be ED. That looks like a 45-degree rotation. And it's not going to be HI because it has to go 90 degrees. So it's going to take your horizontal line to a vertical. So, and it said about point P. see. So here is our segment. And we're rotating it about point P here, and we're going to go this direction. So turn, and you can tell, hopefully, it ends up being over here. So whatever the one is right here, F, G. So that's how you would deal with that one. Number 4, using flags to signal a message. And that's how you do Q. How are we going to take right hand flag to the left hand? And you are going to rotate it. If we go clockwise, looked like it's about 135 degrees. That's good. That looks like it's right. Without, they don't tell us exactly, but it sure looks like that's about 135 degrees. So I would take it. I would appreciate that they would give us more information to know for sure the angle there, but that's good on number 4. Okay, on number 5, here are 2 polygons. What translations, rotations, and reflections would take P to Q? So we're going from here to here. All right. I'm looking back because it looks very similar to this one over here. I think it may be the same figure, but it's not all of the same. But I think it's actually the same question as what's here. It's just a slightly different figure. So hopefully now that if you watch the other video, that helps you a little bit. But I'm going to go through it anyway, just in case. So we've got this figure here that is figure P. And it's slightly different than the other one, but very, very similar idea. And number A, or letter A, says to rotate it 180 degrees. So here's my vertical line, and it's when I rotate 180, it's going to be back to vertical. So there's a 90 degree, and there's a 180 degree. And you can tell that's not the same as that one. So it's not A. Translate so that A goes to J. So we're going to slide it over 2. So that's going to take B to where A is. So we're going to take it from here to here. And then we're going to reflect it over line AB. And so it's going to flip. If I fold it right, it should. Hopefully you can tell it ends up the same. It's a little bit off just because the paper's at an angle, but it's really close. So that one is correct, yes. Part C, rotate it 60 degrees. So earlier when you had that circle on this one, you said it was going to rotate 60 degrees, but that's a little bit different question because this is inside of a triangle. The triangle is inscribed in the circle. And this one, we've got a bunch of triangles next to each other. So yes, you are rotating triangles, but on this one, you're not rotating the triangle so that it's like back onto itself. You're just rotating it until this side lines up with this side, for instance. Like you're turning it here. You're not trying to get that triangle back so that it's turned the same way. It's just taking it from here and then turning it a little bit. Like, let me see if I can draw it. So you're taking this triangle, and then if you rotate it 60 degrees, it ends up here, whereas the triangle that we had just drawn would have been in this direction. So it's not positioned the same way. It went from being like this to now it's turned a little bit different. So on part C, rotate it 60 degrees around point A. So take this one here, and let me see if I can find my triangle line. There's one right there. So I'm going to take this line, and it says counterclockwise, so I'm going this way. I almost would say to the left, but I don't know if that might confuse you more. So turning away from the clock. And so we end up here, and then flip it over FA, which FA is here. So we're going to flip it this way. Which does not look like what they had. So let me make sure I did that correctly. Rotate about point A 60 degrees. So 60 degrees would put us here, and then rotate it over FA. So no, it ends up like this, and the figure underneath it is more like this. So I don't think it is C. Then D says reflected over line BA. So we're going to take it and then reflect it this way. So another way to reflect is to just flip your paper over and then go line A and B up, because that's what you were reflecting it across. So it says reflected over BA, and then rotate it 60 degrees around point A. So then 60 degrees counterclockwise. So still going the same way we've gone. Well, I guess I need to draw. Goes from here, and then there's the other side of the triangle. So that still does not look like the triangle, or the, not triangle, the polygon underneath it. So it's not D. And then the last one, reflect over line AB. So flip your paper over and then translate it by BA. So we're going to slide it to like right here. And it's hard to tell, but that figure is like right in there. And it is a little bit off, but again, that's also just because the paper is at just a slight angle. But it's in this it's very, very close to each other. Like they're off just a little bit. So it should be B and E for your answer on that one. Then number 6, given angle ABC and the directed line segment U. So you are going to you're taking and then however long U is how far over you slide it. So if it's about that long, then you're gonna slide from this point until it is to the end of that point. So I'm going to put a darker point so you can kind of tell maybe. So I'm going to make this point move until it is on top of where that point is. And so we're just going to slide it over. And so it ends up, I mean, you had the right idea, but your angle should be more like right here. But basically the same. A prime, B prime, C prime are kind of over here now. So, well, C should be more like right here. But basic idea, you have it drawn correctly. It just needs to be a little bit closer because it only moves, let's say that's an inch. It's only going to move over about an inch. So that'd be part A. Then part B, explain why AB is parallel to the line containing A prime, B prime. We slid it over. It's not just because they're congruent, because if I took this segment and then I moved it over to here, and then I have it here to here, and these are both a half an inch, let's say. They're congruent, but they're not parallel. The reason that they're parallel is because it was a slide and a translation is a rigid transformation. And so a rigid transformation, which is your rotations, reflections, and your translations. But this one specifically was a translation because it translated it. You just slid it over. A translation keeps the shape, size, and orientation, the direction. And so that is why they are parallel, because it was a rigid transformation. Okay, last one, number 7. We have a sequence of rigid transformations that takes A to A prime, B to B prime, C to C prime. And then it also takes D to D prime. Draw and label it. So it doesn't ask what transformation would take, or like how you would get there. It just says to draw where D is. So here's A, here's B, and here's C. And D, I couldn't see it for a second. D is right there. And so I am going to rotate, and now it is on the same thing. I've got A here where A prime is, B here where B prime is, and then C here where C prime is. And so that means that D, it's going to go right here. And so there is D prime. So that's what you would do. So it looks like it would just be a rotation of some sort, and that's how you're going to get D to D prime. So hopefully that helps a little bit.